Hello everyone. So, welcome back to the course on machine learning using Python programming. In the last lecture we have seen k-means clustering, and in today's lecture we will see the extension of that and we will see what is the problem that we have in k-means clustering and that what is the solution of that. So, that solution is k-means plus plus algorithm. So, let us see first what is the problem and then we will see how we solve it in k-means plus plus algorithm. So, the problem is in k-means clustering, if you remember, the first step was we were randomly choosing centroids or the number of centroids. That number, first of all we need to decide how many clusters we want, and that number of centroids we were randomly choosing. So, let us see what can happen if we will choose these centroids randomly. Suppose these are the data points and we are choosing these centroids randomly from the data points in these three places. In that case, your clusters will be forming like this. There are more chances that one cluster you will get here, one cluster here and one cluster here. So, these three clusters you will get. But suppose your randomly chosen centroids are these three centroids. So, now you see the centroids that you randomly chooses are now changed, and there are many chances that your clusters will be like this. So, one cluster you will get here, one cluster you will get here and one cluster here. So, you see data is same, but depending on the centroids that you are choosing randomly at the initial point, you are getting different clusters. So, this is called as random initialization trap. So, random initialization trap, you are initializing randomly, and because of that your output is totally different. Your clustering algorithm output, or you can say that k-means clustering algorithm output is different. So, what is the solution? Solution for this is k-means plus plus algorithm. So, let us first see what we were doing in k-means clustering algorithm. K-means algorithm iteratively assigns each data point to the nearest centroid and updates the centroid location based on the new cluster assignments. So, but the initial phase we have taken these centroids randomly, this was the main problem. So, what we do in k-means plus plus algorithm, how we are solving this problem. So, to perform better than k-means algorithm, what we do, we number of clusters, definitely it is not known a priori. So, in k-means plus plus we select initial centroids in some better way. So, we are not choosing these centroids randomly, and in this way we are trying to improve the performance of the algorithm, because we are using some smart way to select these initial centroids. In the first step, the centroids that we were choosing randomly, now we will choose some method, and by using those methods we will try to select these centroids. So, what is the idea in choosing these initial centroids? The idea is that your initial centroids should be far apart from each other. So, if these centroids are far apart from each other, then there are chances that you may get better clusters as an output of your algorithm. So, let us see how we will select these centroids that are far apart from each other. So, these are the steps of k-means plus plus algorithm. First of all, initialize the first centroid randomly from the data set. So, if we are assuming there are 3 clusters or there are 5 clusters, then the first centroid that we will choose, we will choose randomly only, as we have done in case of k-means algorithm. But in k-means algorithm, all 5 clusters centroids we choose randomly. Here only the first centroid we choose randomly, and then second, third, fourth and fifth, or whatever number of clusters we want. So, remaining centroids we do not choose randomly, there is some method and we will see what is that method. Using that method we choose the remaining centroids. So, let us see what is this method. So, after initializing the first centroid randomly, in the second step we will do, for each data point we will compute minimum squared distance and we will store it in a list. So, what we will do, basically we will for each data point we will compute its distance from the initially randomly chosen centroid, and then we will take a square of that distance. Then in the next step we will randomly select next centroid from the data set using a probability distribution that is proportional to the minimum square distance of each data point from the nearest centroid. So, basically what is done here, the idea is we will choose that data point as a next centroid that is farthest from any of these previously chosen centroid. So, till now we have chosen only one centroid. So, we can say that we will calculate distance of all the data points from this centroid, we will take a square of that distance, and then there are chances that the point data point will be chosen as the next centroid that will be farthest from this centroid. So, we will repeat these two steps, second and third steps, until all k centroids have been selected, and when all the k centroids will be selected, we will run a standard k-means algorithm to find k clusters. Let us see how we can do this, how we can implement it. So, after finding probability of each point, we will need to calculate cumulative distribution function. This is only for the implementation purpose, how we can implement the idea that we have seen here. So, first of all we will sort probabilities of each data point in ascending order, means the data point that is closest to the centroid that we will keep first, and then the data point that is far from that centroid that comes later, and so on. Then normalize the sorted probabilities so that they can add up to 1. So, we generally normalize always these probabilities, because we want sum of these probabilities should always be 1. So, this can be done by dividing each probability by the sum of all probabilities. Then we can calculate cumulative sum of the normalized probabilities. So, resulting cumulative sum will represent cumulative distribution function of the probability distribution. So, we will see one example where all these steps we will perform. So, then how to select a random point based on the probability distribution calculated. It means we want to now check how the next centroid we will select based on these probability distribution, because this probability distribution is proportional to the squared distance. So, now we will see how we will select the next centroid. So, to select a random point based on the probability distribution, we generally use weighted sampling approach. So, what are the steps here in weighted sampling approach? We first calculate cumulative distribution function as we have seen earlier. So, we will calculate cumulative distribution function of the probability distribution that is obtained in k-means plus plus. So, after getting distance, we will take a square of that distance, then we can take convert it into probabilities, and then from that probabilities we can calculate cumulative distribution function. So, then how we will select the next centroid. So, we will generate a random number between 0 and 1, and then using cumulative distribution function we will find the data point whose cumulative probability is greater than or equal to this randomly generated number. So, this can generally this can be implemented using binary search or linear search algorithm, but the idea is that what we want to select data point as an X centroid that is farthest from each of these centroids. So, that is why we are taking probabilities, we are defining probabilities that are proportional to the square distance of these data points to the nearest centroid that are decided till now. And then we are not always choosing the point that is farthest from these centroids. So, for that what we are doing, we are implementing like this, we are generating a random number between 0 and 1, and whatever random number we are getting. So, we are using this cumulative distribution function that we found using the probability distribution function that we talked about. So, using this cumulative distribution function, we will find the data point whose cumulative probability is just greater than or equal to the random number that is generated, and that data point we will select as the next centroid. So, let us see these steps in as an example. So, we will see here two examples, and in the first example we will exactly see the steps that we have seen in the previous algorithm, and to make it simple we will see the second example, so that it would be easy to understand what is done in k-means plus plus algorithm. So, in example 1, let us have this data set of 10 two-dimensional data points. So, they are in your data set, there are 10 data points, and this is two-dimensional data point, and what we want to cluster these points in two clusters using k-means plus plus. So, in k-means plus plus, the first centroid we will need to take randomly. If we suppose use k-means algorithm, in that case the both centroids we can choose randomly, while in this case only the first centroid we will choose randomly from the data set, and in this case suppose randomly chosen data point is this one 2 2. So, 2 2 we are taking as the first centroid. Now, what we will do, we will calculate a squared distance between each data point and the first centroid. So, here we can find distance of 1 1 with centroid 2 2, distance of 1 2 with centroid 2 2, distance of 2 1 with centroid 2 2, and so on. So, this is the squared distance. So, using Euclidean distance we can find that distance, and we will take a square of that distance. So, this is the list that we formed. So, till now we have created only one centroid. So, distance is taken only from this one centroid, but suppose we have chosen means in the second step where we found two centroids, first random centroids and second centroid. By following this method, suppose we got another centroid, then to find the next centroid, how we will perform the second step. So, here we will take the square distance of each data point with both of these two centroids, but for each data point we will keep that distance that is less distance. So, suppose we will calculate distance of 1 1 from 2 2 as well as distance of 1 1 from another centroid that we got in the second step. So, and distance of 1 1 with 2 2 is less than distance of 1 1 with the second centroid. So, here we will keep square of that distance. In the same way, for second data point, whatever distance is less, we will take the square distance of that, and in this way we will find this squared distances, and then will define the probability distribution of these data points, that is proportional to this square distances. So, how we will do it? Will simply we can will divide these distance, this square distance, by sum of all these square distances. So, we will get these probabilities. So, let us see the example, remaining example. So, how we will perform the third step. So, suppose the randomly generated number that we will generate between 0 and 1. So, suppose that randomly generated number is 0.7. So, we will need to calculate cumulative distribution function. So, these are the probabilities, this is the probability distribution. So, now from that probability distribution we can find out cumulative distribution function. How we will get it? This is the first probability. So, same probability we can write here. Then cumulative distribution function, we take sum of these two, that is the second probability, and then we will take sum of these three, that is the third probability here in cumulative distribution function. Then sum of these 4 will give you the fourth probability here, and so on. So, in this way this is, so finally when you will sum all these, because all these are the probabilities, so you will finally get value 1. And then since the randomly generated number was 0.7, so here we see this 0.7. so this is the number that is just greater than or equal to 0.7. so this probability was less than 0.7, this is greater than 0.7. so we will see the index of the data point, that the probability of that was added to the previous probabilities, and when that after adding we are getting this number. So, that data point was at index 7, and that index 7 data point is 4. So, this is the data point that will be selected as the next centroid. So, now we got 2 centroids, this was randomly chosen, and this is the centroid that we got using k-means plus algorithm. So, after getting these 2 centroids, since we need only 2 clusters, so we will perform k-means clustering with these 2 centroids. So, we will get 2 clusters, and then we will again calculate centroids out of that. So, we will repeat steps 2 to 4 to select additional centroids. So, here we assume that we need only 2 clusters. So, we can apply here k-means and we will get the final clusters, but if we want more clusters, so we will apply these algorithms, these steps again and again until the desired number of clusters is reached. So, in our case the final results after 2 iterations will be, this is the first cluster and this is the second cluster. Now, we will see another example where we will talk about 3 centroids or 3 clusters. So, it will be more clear how we can select remaining centroids after selecting the first centroid randomly. So, suppose here we have 7 data points in and all these means your data set is one dimensional data set. So, these are the data points, and we want here 3 clusters. So, we will need to find out 3 centroids. So, in case of k-means algorithm, all these 3 centroids will be selected randomly, while in case of k-means plus algorithm, the first centroid will be taken randomly, but remaining 2 centroids we will take based on the previous algorithm that we have seen just now. So, the first step, we need to choose first centroid randomly. So, suppose the chosen random centroid is 8. So, we are choosing this data point as the first centroid. Then calculate distance for remaining data points to this centroid, and we will take a square of that distance. So, these are the data points, and distance of all these data points to the randomly chosen centroid, that was 8. This is the distance. So, we can use any distance metric and we can find these distance. Then we will calculate a square of this distance. After calculating a square of this distance, since we want to choose the next centroid with weighted probability that we have seen earlier. So, we will take sum of these square distances. So, sum of these squared distances is, suppose one means when we will sum these values, we will get 163, and then these so will these were the square distances, this was the sum of these square distances 163. So, we will divide all these square distances by sum of all these square distances. So, we can say that we are getting now probabilities. So, we can, when we will implement, what we can do, we can generate a random number between 0 and 1, we can generate cumulative distribution function out of this probability distribution, and then we will find out the data point whose probability was added to the previous probabilities, and that is just greater than equal to the random number generated between 0 and 1. So, in that case, that data point we will choose as the next centroid. But here, for the sake of simplicity, I am assuming that we will select the next centroid, that data point for which that this probability is high, because this probability is proportional to the distance of the data point from the centroid. So, in this case, we can find out that there are two data points 1 and 15 for which this distance is, this probability is highest. So, let us choose first data point as the second centroid, because these probability corresponding to these are highest. So, out of these 2 points 1 and 15, we are suppose randomly choosing 1. So, 1 is the second centroid, 8 was the first centroid, and we will need to choose third centroid. So, how we will find out the third centroid? We will find out distance of each data point with the second centroid, with the first centroid, and we will take that distance that is less. So, here you can say this distance is 0, this distance is 7. So, minimum distance is 0. So, minimum distance of first data point with any of these centroid is 0, minimum distance of second data point with any of these centroid, with these centroids is 1. So, these are the minimum distances. So, and then we will take a square of these distances. After calculating a square, we are dividing these square distances by sum of these square distances. So, we are getting, we can say that we are getting again probability that is proportional to the distance of these data points with the clusters, and we are having two clusters. So, we are here, we are considering those distances that are less, and after this again we can find out which probability is the maximum probability. So, in this case for data point 15, the probability is maximum, that is 0.62. So, it means its distance from the nearest centroid is maximum, and that is why we can take this as a third centroid. So, we got 3 centroids in this case, first 8 and 15, these 3 data points we got. So, first centroid, that was 8, we selected randomly, but the second and third centroid we selected using k-means plus plus algorithm, and after finding these 3 centroids, we will apply regular k-means clustering algorithm, and and we will do it until we will get the convergence, or we can say that until we are getting the final clusters. So, in this way we can improve the performance of the algorithm as we have seen in k-means algorithm, all the initially selected centroids were randomly selected, but in case of k-means plus plus, only first centroid we selected randomly, but remaining centroids we selected based on the distance of those data points from the centroids till now, and that is why we may get better clusters in this case. So, I am stopping here. In the next lecture, we will see some other clustering algorithm or techniques. Thank you.